Right, so let's look at an example question. I just need to find the specific, I think the specific capacity of water is 4,200 joules per kilograms per degree C, but let's just check that for certain. Yeah, that's pretty much it. It's obviously rounding up, but we're going to just use that figure. So specific capacity of water, I'll use a little subscript W there, is equal to 4,200 joules per kilogram per degree C. You may see this written as joules, and then you got kg to the -1 and degrees C to the -1. And after I've gone over this a little bit on units, hopefully that's a little bit less confusing now. But I won't elaborate on that now. So, okay, so that's the specific heat capacity of water. Let's imagine we had 3.5 kilograms of water, and I'm going to give it, say, 500 joules of energy. Then how much, and let's say the starting at the moment, it is the temperature at the moment is, let's say it's 18 degrees C. So what would be the temperature after I've given it that much energy? So you may want to pause the video here and work it out, and then when you unpause it, I'll go through the answer. So I'll presume now you've just unpaused it, and so let's just use this formula up here. E equals mc times delta T. Now we're going to rearrange it for delta T. So delta T is equal to energy over the mass times the specific heat capacity, which is 500. I'm seeing already it's going to be a very small number. 500 divided by 3 point. In fact, no, I'll leave it like that. 500 times 4,200. I should have been able to see that that's going to be a small number actually, because it says for 1 kilogram it's going to take 4,200. We've got 3.5, so it's going to obviously going to increase the temperature by much less than a degree C. So I should have thought about that, but never mind. Okay, so yeah, running it through the calculator, we've got a very, very tiny change in temperature. It's 0.034, rounding up to two significant figures, degrees C. Not the best example, really. I probably should have said 5,000 or even 50,000. So let's do that actually then. How much would it be? What about if I were to, in fact, I'm going to multiply it by, I'm going to do the same thing. In fact, you're going to do the same thing. And this time the energy is the same amount, same mass, but this time the energy is 50,000 joules. Okay. And yeah, and see if you can use a shortcut there as well. So I'm going to assume that you've unpaused it now, and the shortcut is to realize that the sum would look exactly the same as this one up here, only the numbers would be like that. And so the answer is going to be that multiplied by 100. So it takes us up to 30. So 30 degrees C. Well, 34 degrees C, isn't it? 34 degrees C. That's right, isn't it? It's 100 times more. Yeah. So what about if it was 1,000 times more? If the energy was equal to, so this is 50,000. Let's imagine if it was 500,000. Well, we can see again it's just going to be another 10 times the amount. So the change in this is the change in temperature, remember. So my notes are terrible here. So we basically shouldn't have an equal sign there. That's what I'm doing wrong. So the change in temperature, and so with the new temperature, we would say 34 plus 18, so that'd be 44 and 52, isn't it? That's right, isn't it? Yeah, 52 degrees C. Okay. What about if it was 10 times the amount, or 10 times the amount again? So we got change of temperature now is 340 degrees C. Right. That would mean that the new temperature is, well, but to be honest with you, even if we don't even need to bother working this out, because the new temperature is going to be over 100 degrees C, and that's an issue. And you may not realize this because I haven't fully explained it, but when I said the specific heat capacity of water, I don't mean H2O, I mean the actual liquid form of H2O. And of course, once you get it up to 100 degrees C, or once you get it past that, then it's not water anymore, is it? It's steam. And steam actually has a different specific heat capacity to water, and also a different specific heat capacity to ice. So basically, we need to know a little bit more about the situation in order to answer that question there. So I'm going to cut this video off here, and then we're going to elaborate on that question in the next video.